part of this three-part lecture series is on software fundamentals. Let's go back to the definition of application for a second. Applications could be on any kind of device, but software is information that is produced into an instructional format that tells the hardware to use this structured data process to complete one or more tasks using this input-output command for a specified need, a goal. So for example, a piece of accounting software has a specific need or goal. Everything is intended to go ahead and be focused on accounting activity. An operating system, as an example of a system software application versus, is really intended to be the back-end operator, to allow the system to run, to be the under the hood orchestrator of all the functionality that allows all the software to operate. So the key thing is instructional format that is in a data process. So an application, there can be many applications in a piece of software, but software is a compilation of many of these applications that is structured into information that allows for input and output commands in a data process. Now there really are two types of software: system software and application software. Let's talk about system software for a second. System software is the back office. And really there's three kinds of system software. We're most familiar with the operating system. The operating system are the programs that coordinate the hardware resources, provide the interface between the end user and the device, and run the applications via some form of graphical user interface, or GUI. Now, we're familiar with like the Mac operating system or Windows operating system, but there's actually 40 or 50 operating systems that are actively used on the market today that are on the desktop or servers. That does include mobile. Now, believe it or not, many devices that you use have their own micro operating systems. So, operating systems coordinate the activity between the interface to conduct the specific function for the user to run those applications, those instructional activities. It could be a specific one or two task activity, or it could be hundreds of thousands of activities. Utilities perform a specific task on a device. Think of an antivirus software application or security software as a form of a utility. Now, device drivers are a kind of executable program. Executable programs run on hardware for specific input and output devices. It talks to specific components that are part of hardware. So for example, software in an operating system may only talk to the CD drive, or the monitor, or the printer. They are specifically called by the operating system if there's a compatibility or a match. Now, application software is function-specific software that allows an end user to complete one or more tasks more productively and efficiently. So obviously the goal is, why go ahead and do it manually? Let's automate things. The software can be standalone or part of a suite of applications. So the most obvious is Microsoft Office. It comes with word processing, it comes with spreadsheets, it comes with database, presentation software, note-taking, and so forth. Many applications have moved from a standalone client-based executable to being delivered by the internet using a cloud delivery service model. So this is the cloud section I've talked about. Now, is cloud delivery not on hardware? Oh, absolutely it is. It's on massive hardware. It's on servers. You know, those mainframes, it's on mainframe kind of software and hardware. It's on supercomputers to some degree. It's on petabytes and zettabytes of data. It's got that much data in it to some degree. That's what Amazon and IBM and Oracle and the big cloud providers have in their data centers. But the fat client, as we discussed earlier, is the software that's stored on a computer versus a computer that just sits there and uses the internet browser to get the software delivered. It's called a thin client. But it doesn't mean that there isn't an application software capability. It's just the delivery mechanism. Regardless, the end goal is to enable the end user to complete an activity that in an electronic means using feature function based experience is successful. That's the goal. End of story. And that's really where computing has moved to, whether it's in education, business, medicine, doesn't matter what industry. Let's talk about operating system software. Frankly, these are the operating systems or the vendors that are the most popular today. Linux is very popular in the server world. Apple, obviously, Mac OS, Windows, I think everyone knows it's about 75-80% of the market. IBM, very popular in the mainframe world. Ubuntu, Unix, obviously that is part of the mainframe supercomputing world. You know, MS-DOS, that's some of the backend Mac OS. Obviously, that's the traditional PC type computer, desktop computer versus Apple being the iOS, Android, BlackBerry, that is the mobile OS. So these are the PC as well as the mobile operating systems that you will hear a lot about in the computing world today. This covers probably about 95 to 96% of the ecosystem. Now, let's talk about device drivers. We've talked about them being executable programs that run on hardware for specific input and output devices. These are called specifically by the operating system if there is a match. Now, what is a device driver called by? What does this mean by a match? Plug and play. Connect a piece of hardware externally. Let's talk about a drive. So say you have an external hard drive or a flash drive or a camera connected to the computer without having to install the piece of software each and every time. You install the software once, or even the operating system recognizes the cable and the camera. There's a piece of software either on the computer or on the device that says, "Hello computer, I am device X. Please recognize me and communicate with me." And it configures the computer with the device to have two-way communication. A great example is printers. Most printers today have device drivers automatically connected. And if they don't, you can download them from the vendor's website. Hot swappable. Remove one device, connect another. This is the same port. So a lot of times you will see people connecting multiple drives. Thumb drives, great example. How many thumb drives do people have? 10. 5. I have 5, 10, 15 thumb drives or external drives. I'll connect it to my USB drive. Oh, couldn't find it. Hot swapping, the port flushes all the activity that was stored in that cache memory and says to the little device, okay, USB drive, you do not match the type of device or the code that's on that device anymore, but I see you're a new device or like the previous device and you're readable. Okay, you're able to be read. That is what a hot swappable device is. So device drivers are simple executable programs that are stored on the device or on the computer that communicate with the device to have that dialogue. Utility software. Utilities perform a specific task on a device, such as protect the system from getting a virus, monitor system from suspicious activity, replicate an operating system environment, or backup activity on an incremental basis. Back office activity. Straightforward. Back office activity. For personal computing, frankly, it's an antivirus usually. For business and educational computing, it really is a mixture of application and utility computing. So utility software, it can be, very, very substantial. Especially with enterprise resource planning, HR, HRM systems, learning management systems. Utility software is used a lot in educational computing, in administrative forums. But if it's in the classroom, it really stays with antivirus and maybe personal firewalls. I don't usually see people doing virtualization or backups of their computers unless they have some kind of need for it. Now, let's talk about application software. This is really the only slide for this one. I'm going to talk about it from a class focus, not an administrative focus. I'm not going to go through each of these individually. This is the top 8 types of software that if you were to look at surveys, in most of the educational journals that they talk about are used in classrooms today. It doesn't really change. Most of it's business office productivity. But as we're seeing more and more of the applications move to the web, which application do we see becoming the only one? The web browser. So everything is moving to the web browser, and all the web browser capabilities are essentially being consumed as part of that single interface. So cloud computing allows for all these applications to be consumed over the internet. I always love to end my lectures with a cartoon. And of course, this guy is questioning the computer by asking him, can't you do anything right? And you know what the computer's going to say? I can only do what I'm told to do. And why is that? And you can answer it because the instruction it's given, if there's not the instructions available, it can't produce the results. So the final thought here is the software can only do as much as it's told to do, and the hardware can only produce the results that the software